guys, so we are going to start our chapter on the mole. It's going to be a lot of math in this chapter, so if you're not real great in math, then you may need some extra help, and we may need to communicate a little more about some of the work and some of the assignments. Now, I realize that I have sent you already a worksheet on dimension analysis, and I've also shown you a video on unit conversions. Since this topic is so difficult, I felt like we needed to address this topic one more time and give you some more practice before we move into talking about converting from moles to particles, particles to moles, moles to mass, mass to moles, moles to volume, and volume to moles, okay? There's going to be a lot of converting between units that you're not as familiar with, so felt it was necessary for us to go over this topic one more time and then move on into the mole chapter, okay? So, if you're following along in your notes, why is dimension analysis useful, okay? So, dimension analysis provides you with an alternative approach to problem solving. Now, as you'll notice, in the United States, we use the English Standard System, but everywhere else in the world, they use the metric system. So in science, because we're continually collaborating between overseas and the United States, and a lot of research data that we'll be comparing both foreign and in the US, we've got to all stay on the same page. So when we're talking in terms of measurement and things in science, we use the metric system. So a lot of you, it's not familiar to a lot of young students to be using the metric system. So it's very important for us to teach you how to convert between these metric and standard United States units, okay? So that's why we're doing this section, and that's why we're doing this before we move into the mole, okay? So most other nations and the scientific community use the metric system. So it's a system of measurement based on multiples of 10. So for example, I'm sure you've learned in your earlier years in math, if I'm going from centimeters to meters, that's the equivalency of 2 decimal places, which is basically 100, okay? So it's multiples, always multiples of 10. So if I have centimeters and I'm trying to go to meters, say I have 50 centimeters, well, that's going to be equivalent to 0.5 meters, meaning I move my decimal 2 spaces to the left because it represents the number of zeros, okay, that a centimeter equals to a meter. So there's 100 centimeters in a meter, meaning 2 zeros. So that's the number of decimal places that I move. Now, because centimeter is smaller than a meter, when you go from a centimeter to a meter, the number value should be smaller than what you previously had, okay? All right, so the International System of Units. So each type of International System measurement has a base unit, okay? So length is meter, mass is kilogram, time is in seconds. Now electric current we're not going to use in chemistry. It's called the ampere. We use that in physics. Temperature, we will be using Kelvin. We don't use Fahrenheit or we use degrees Celsius, but we typically always convert that into Kelvin because in the Kelvin scale there are no zeros, and we'll talk more about that later. What we're really going to be focusing on this chapter is the amount of a substance, and that is the mole, and the symbol or abbreviated unit that we use for that is MOL, not MOLE, okay? MOLE is the animal mole, and MOL is the unit of mole. And then last we have intensity of light, which is candela, which is also used in physics, not chemistry. Okay? Now, say for example you have a rattlesnake, okay, and it is 2.44 meters long. How long is the snake in centimeters? So it's kind of a multiple choice answers. We just talked about this a second ago. So if I have 2.44 meters and I know there's 100 centimeters in a meter, okay, and I'm going from meters to centimeters, I just told you if I go from centimeters to meters, my number should get smaller by that many decimal places. Well, here we're going from meters to centimeters, which is opposite of that. So that means my numeric value should get larger, okay? So instead of dividing by 100 here, I would have multiplied by 100. So 2.44 times 100, I'm moving that decimal place 2 spaces to the right, So therefore I should have 244 centimeters, which was B. And let's check our answer to see if we did this correctly. So when you are setting up, anytime you are setting up a measurement, you always start with the given quantity in the problem. And sometimes you can either write it like this, or a lot of people like to write it in ratios, so you could put that over 1. So 2.44 meters over 1. Your ratio here is 100 centimeters over 1 meter. Now I think my converting from PowerPoint into Google Slides messed up my the distance I have over here, so I'm going to fix that slide. So this should be 1 meter right here. And the reason I have the slash here is you're canceling out meters and going to centimeters. So in essence, you're taking 2.44 times 100 over 1, which would give me 244 centimeters. Okay? Now, what about square and cubic meters? Okay? So use the conversion factors you already know, but when you square or cube a unit, don't forget to cube the number also. Okay? So for example, if I'm converting 4.3 centimeters cubed to millimeters cubed, I know the difference between a millimeter and a centimeter. So centimeters here and a millimeter is right below it. So there's a difference of 10 there. Okay? So there's 10 millimeters in 1 centimeter. All right? So if I know that, I need my units of centimeters to cancel out. So when I set up my ratio here, okay, I'm going to put 10 millimeters over 1 centimeter. Now, because my units here are cubed, I have to cube my ratio. Okay? So I have to cube my ratio. Now, when I do this, I'm going to have 4.3 centimeters cubed. Now, when I cube this 10, it's going to be 10 to the third. Okay? Millimeters cubed over 1 cubed and centimeters cubed. Now, you know 1 cubed is just going to be 1. And then when we cube the 10, okay, we're going to multiply it by itself 3 times, basically, is what you're doing. So, 4.3 times 10 cubed divided by 1 is going to give me 4,300 millimeters cubed. All right? Now, a Nalgene water bottle holds 1,000 centimeters cubed of dihydrogen monoxide, so that's a fun way of saying water. How many cubic decimeters is that? Okay? So, the difference between a decimeter and a centimeter is 10. But the decimeter is actually above the centimeter. So, when we're looking at that, it takes 10 centimeters to equal 1 decimeter. So there's going to be 10 centimeters in a decimeter. So if we set that up, we have 1,000 centimeters cubed, and we know the ratio is 1 decimeter equals 10 centimeters. Okay, same thing. So here's our conversion. We're going to set that up in a ratio. And sometimes people often ask, how do you know how to set up the ratio? Well, you want your units of centimeters to cancel out. In order for you to cancel a unit, they have to be diagonal of each other. They cannot be side by side, because if you multiply them, that becomes the unit squared. Okay? So you have to have them diagonal in order to cancel the units out. So all I have to do here is I know what my ratio is, and because that unit is cubed, I just cube the whole ratio. So my 1 gets cubed and my 10 gets cubed. So now in this problem, I'm going to take 1,000 times 1 cubed divided by 10 cubed. And that's going to give me an answer of 1 decimeter cubed. So a decimeter cubed is the same as a liter. So that means a centimeter cubed is the same as a milliliter. Okay? Now, we're going to use dimension analysis in a real-world lab problem, okay? So the directions for an experiment ask for each student to measure 1.84 grams of copper wire. The only copper wire available is a spool with a mass of 50 grams. How many students can do the experiment before the copper runs out? So what do we need to look at here? We know that we're starting this problem out with 50 grams. That's what we know that we have. So remember, when I was talking to you about the number given is always what we're going to start the problem at. So we're going to start this problem out at 50 grams over 1. The next ratio needs to look as if we can cancel units out. So we want to cancel grams out, so we need what? 1.84 grams on the bottom of the ratio, and we're going to use 1.84 grams per student, per one student. So the way you would set that ratio up is you'd have one student over 1.84 grams, and you're going to multiply that ratio times 50. Okay? Now, when we would do that, okay, and I don't think my smartboard is working right now, so I'm going to turn my computer a little bit so I can show you guys how to do that. So take a pause there, and I'm going to show you the board. Okay, here we go. So what I'm going to do here is I'm going to show you on my board how to do this problem. All right, so in this problem we have 50 grams of copper wire. And we're trying to figure out how many students can do the lab with 50 grams of copper wire. So we know that for every one student, we need 1.84 grams of copper. We started out with 50 grams of copper. So they will cancel, and you're going to have 50 times 1 divided by 1.84. So we grab our calculator, and we say 50 divided by 1.84, and that's going to give us 27 students. Now, if you looked at your calculator, it would have actually given you a number of 27.1. But as you know, we can't have a 0.1 student, right? So we would round that number to a whole number and say 27 students would be able to do this lab with one spool of the copper wire, okay? Slide back over. Okay. So now, okay, conversion factors. So that's what I was just showing you in that example. That's a conversion factor. So when a measurement is multiplied by a conversion factor, the numerical value is generally changed, but the actual size of the quantity measured remains the same. So a conversion factor is a ratio of equivalent measurements. Okay? Now, we're done with this video. So thank you. I'll talk to you later in the week when we're going to talk about the mole, okay? And talk a little bit about moles and particles. All right? So I'll see you soon.